Okay, the next thing in your notes that we're looking at is this of solving cubic equations. Okay, so I'll work through these examples and that will help you then hopefully to go on and do exercise 7D. Okay, so then what we're looking at when we're solving a cubic equation is to factorise first, and then we factorise as far as we can go and then apply the null factor law. So what we've got here in this example 1 is a cubic which is already factorised. Okay, so we've got 3 linear factors here, and to apply the null factor law, okay, the null factor law says that if we have factors being multiplied together, say a times b, and that equals 0, then either a equals 0 or b equals 0. And so here we've got 3 factors, so it's a situation of a times b times c equals 0. So either one of these could equal 0. All right, so that means that either x minus 2 equals 0 or x plus 1 equals 0 or x plus 3 equals 0. And for this to be true, then that means that x equals 2. For this one, x would equal -1, and this one, x equals -3. So these are our 3 solutions to this cubic equation. All right, the next one we have here is 2x cubed minus x squared minus x equals 0. So in order to factorise this one here, whenever you're factorising, you're always looking to see if there's a common factor throughout. And we can see here that there is a common factor of x. So we'll take that out first. That leaves us with 2x squared minus x minus 1 equals 0, which means that either x equals 0 or 2x squared minus x minus 1 equals 0. So this is one solution we have. Now we have to look and see whether we can get solutions from this. Okay, so we look to see, it's a quadratic, this one here. So we look to see, can we factorise it? Well, we're looking to see if we can factorise, then we're looking for 2 numbers that multiply to give the product of 2 and -1. So 2 times -1 is -2. So we're looking for 2 numbers that multiply to give -2 and add to give -1. Okay. Now for that to happen, then our 2 factors would be -2 and +1. -2 times 1 is -2, and -2 plus 1 is -1. So these work. So what we then do is we split up this middle term, minus x, into -2x and plus 1x. So 2x squared minus 2x plus x minus 1 equals 0, and then factorise by grouping. So we factorise these first 2 terms, 2x outside of x minus 1, and then the common factor between these two is plus 1, so we write plus 1, leaving us with x minus 1 equals 0. So we know we've done it right if in these brackets we have the same expression. And so then we factorise here, common factor of x minus 1, and that leaves us with 2x plus 1. Okay, so our quadratic here can be factorised to x minus 1 times 2x plus 1 equals 0. That means that x minus 1 equals 0 or 2x plus 1 equals 0. Which means we have x equals 1 or 2x equals -1, which would be x equals -1 half. Okay, so our solutions are x equals 0, x equals 1, x equals -1/2. All right, next one, we do the same thing, look for a common factor. So we can see there's a common factor of x here, leaving us with so we can see there's a common factor of x here. So we've got x outside of x squared plus 2x minus 10 and equals 0. So then we have a solution of using the null factor law here of x equals 0, or x squared plus 2x minus 10 equals 0. So now we've got this quadratic equation we have to deal with. And we're looking to see, can we factorize that? Well, we'll be looking for two numbers that multiply to give 1 times -10. So two numbers that multiply to give -10 and add to give 2. Well, we've got 1 and 10 would be possible factors, or 2 and 5, but any combination of positive and negatives is not going to work here. So there's nothing in that. So we would have to either factorize by completing the square or using the quadratic formula. We can check to see whether there will actually be a solution by using the discriminant, which is b squared minus 4ac. b is our 2, so that's 2 squared minus 4 times a is 1 times -10. So we've got 4 plus, because it'd be negative times negative here, times positive, so that's plus 40, so that's 44. Okay, so then we've got a positive value here, so we know there are going to be solutions to this quadratic equation. Probably the best thing to do would be, easiest would be to use the quadratic formula, which is -b plus or minus square root of b squared minus 4ac over 2a. Okay, -b, so it's going to be -2 plus or minus b squared minus 4ac, which we have already got here, so that's plus or minus 44 over 2 times a, which is 1. So we've got -2 plus or minus. We'll simplify this, okay, reduce this surd down. So square root of 44 is the same as square root of 4 times the square root of 11. The reason I chose those numbers is because I know 4 is a square number, and that's the same as 2 times the square root of 11. Okay, so we always look to see whether we can simplify that down. Over 2, -2 over 2 is -1, plus or minus 2 root 11 over 2, and those 2's cancel. That leaves us with square root of 11. So our two solutions, or our three solutions are rather, x equals 0, -1 plus square root of 11, or the -1 minus square root of 11. All right, the next couple of examples on that same page are these. Now with these ones here, factorising them, we can see that there's not a common factor throughout. But if we look closely, we can hopefully see that we could, if we were to factorise them by grouping, that will work. Okay, because here we've got a common factor between these two terms of x squared. So I'm going to write x squared there, leaving me with x minus 4. Okay, it takes a bit of practice to look and to see these. And here we've got a common factor of 11. And what I'll do is I'll take out actually -11, leaving me with x minus 4 here as well. We know that if I was to re-expand this, I'd end up with those, and re-expand this, then I'd end up with that. And we know that factorising by grouping here will work because in these brackets we've got the same expression. Okay, so that's equal to 0. So now what we can do is, because we've got what's in the brackets here is the same, that is a common factor of this term and this term, leaving me with x minus 4 outside of x squared minus 11. So now I can apply the null factor law. Okay, x minus 4 equals 0, or x squared minus 11 equals 0, which means x equals 4 or x squared equals 11. Okay, now for x squared equals 11, that means that x will equal plus or minus the square root of 11. I say plus or minus because positive square root of 11 times positive square root of 11 will give me 11, but also negative square root of 11 times negative square root of 11 will also equal 11. If we had another example, something that's slightly simpler, say I had x squared equals 4, what I'm saying is, what number squared gives me 4? Well, it will be positive 2 squared will give me 4, but also negative 2 squared will give me 4. So whenever I've got a situation like this, I need to consider both positive and negative solutions. Okay, I'll just get rid of that. Okay, so here's my solutions then. X equals 4 square root of 11 or negative square root of 11. Okay, so with a cubic equation, you can have, in a sense, you could have 0 solutions as a possibility. You could have 1 solution, you could have 2 solutions, or you could have 3 solutions, but no more than 3. So 3 solutions is the maximum. And so you need to look at the possibility of there being 3, but there can be less. Okay, let's look at this one here. Okay, this one actually is similar to what we've got here. Okay, it can be divided up by grouping. So if we take x squared outside of those first two, we'll be left with x minus a. If I take out negative 11 here, that'll leave me with x minus a as well. So this is like a bit more of a general type example similar to this, where a really represents any number at all. X minus a then will be in the first set of brackets, and the second set will be x squared minus 11. So then x equals a, or here is the same as this one here, plus or minus 11 are our possible solutions.